So we did this problem in lesson 29. So how many tenths are in 2? Well, there's 20 tenths. And we know that that's the answer to this problem. That's the answer to 2 divided by 1/10, because in division, we're basically asking how many tenths are in 2. When we say 2 divided by 1/10, that's another way of saying, well, how many 1/10ths are in 2? So division expressions, all division expressions, can be rewritten as a fraction. So if we were to rewrite this division expression as a fraction, we would write it like this: 2 over 1/10. Now that fraction looks a little different than what we've seen before. So what's different about it? Yeah, there's a decimal in the denominator. So it might seem a little weird to see a decimal in the denominator, but I promise it's a perfectly legit fraction. So we can rename this fraction so that the denominator is a whole number. So how can you rename a fraction without changing its value? Well, when we're changing fractions but not changing the value, that's when we get into our do it to the bottom, do it to the top. As long as we do the same thing to the numerator and the denominator, whatever we come up with will not change the value of the fraction. The digits will be different, but the value will still be the same. So if I want to turn 1/10 into a whole number, I'm going to multiply it by 10 because it's a tenth. So I do it to the bottom, do it to the top. So 2 times 10 is 20. 1/10 times 10 is 1. Well, now we have just 20 divided by 1. So to write out what we just did, we had 2 and 1 over 1/10 times 10 tenths. Now 10 tenths is the same as 1, right? So multiplying something by 1 doesn't change the value, but it gives us a fraction that's easier to work with. 20/1, pretty easy to work with, because in our head, we can easily see, oh, 20 divided by 1, 20. So these fractions, shown as division expressions without the quotients, would look like this. 20 divided by 1. 40 divided by 2. 100 divided by 5. And 200 divided by 10. Now all of these division sentences, what do they have in common? The answer is 20. They all equal 20, which means all of those fractions have the same value. They're just different ways of expressing it. So 100/5 means the exact same thing as 40/2. They all equal 20. So since all of the quotients are equal to each other, they all equal 20, can we say that the expressions are equivalent as well? So remember, equivalent means the same. Are all those expressions the same? Do they all mean the same thing in the end? Yes, they do. So that equal sign right there means that 2 divided by 1/10 is the same as 20 divided by 1, which is the same as 40 divided by 2, or the same as 100 divided by 5, and the same as 200 divided by 10. They are all equivalent. Now let's use our thinking above to find the value of this expression. So what do we think the quotient might be? Remember that dividing 2 divided by 2/10 is asking how many 2/10 are in 2. So why don't we count by 2/10? So we have 2/10, 4/10, 6/10, 8/10, 1, 1 and 2/10, 1 and 4/10, 1 and 6/10, 1 and 8/10. There we are, 2/10. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 2 divided by 2/10 equals 10. So let's rewrite it as a fraction, like we talked about earlier. So 2 over 2/10. Now that denominator, still a decimal. It's a decimal. So how can we think of a way to make it a whole number? Well, let's do just what we did last time. Let's multiply by 10/10. So we have 2 times 10/10, which is going to give us 20 halves. And then we know how to reduce that. 10/1, which you and I usually like to call 10. Now what if that divisor was 3/10? If we multiplied by 10/10, what would the new denominator be? Well, 3/10 times 10 would be 3, so the new denominator would be thirds. What if the divisor were 8/10? Well, then our denominator would be 8. Or if it was 1 2/10 and we multiplied by 10/10, then it would be 12. So what are you noticing about the decimal point and the digits that we're using to rename? Well, when we multiply by 10, we're just moving that decimal over 1 and over 1 and over one place. So if we multiply that fraction by 10/10, just like up there, we get we get 20 halves, which is the same as 20 divided by 2, and that equals 10. So let's go ahead and check our work. To check our answer, we multiply the quotient by the divisor to see if we can get back to the original dividend. So if we have 10 times 2/10, we get 2. Oh, look, there's our 2, there's our 2/10, and there's our 10. Everything matches up. Awesome. So go ahead and make a prediction. What do you predict the quotient will be for this expression? I'll give you a hint. We have 2 4/10 and 2/10, but you might want to think of it as 24 divided by 2. Go ahead and show me your prediction and get a smelly star before you move on. So let's rewrite our division expression as a fraction. So 2 4/10 over 2/10. So this time we have a decimal in both the divisor and the whole. So what are we going to do to rename the divisor as a whole number? We'll use our same trick. We'll multiply by 10/10. So what will happen to the numerator when we multiply by 10/10? It will become 24. So now we've ended up, we have 2 4/10 over 2/10 times 10/10, and that equals 24 over 2, which, if we write it as a division expression, 24 divided by 2, which equals 12. Cool. Go ahead and show me this problem using the exact same method. Raise your hand if you want me to come watch you do it and make sure you're on the right track.